Okay, so I want to make a quick video about how do we access open write to files, files that are saved on our permanent storage on our device. This is important because up till now we've talked a lot about how to write programs, but those programs kind of live in the moment that they run, and then when they're done running, pretty much any evidence of the work we've done inside them is gone. So saving files in your program is a way to sort of maintain the state of the program throughout the use of the program on a permanent device. Obviously, this is going to be a fairly simple approach. We're going to use this more when we talk about how we're going to build our user database in the next coming videos. But for now, I just wanted to show you quickly so that when I do that later on, you have some understanding of exactly what I'm doing. So to begin with, let's just make a few comments here. This is basically how do we open and create and write to a text file. And we're going to start off with a text file because I think that's sort of the easiest to understand. So basically, we're going to use the letter F to stand for file, and we're going to use the built-in function open. Now, open is going to work if there is a file and if there is not a file. And if there is not a file, it's simply going to make a file. The other part of open, if you look at our doc strings here, one, we have sort of the file path or descriptor, the name, with just a file name like test.txt. It's going to save it into the folder where we're doing our work right now. We could theoretically provide a more in-depth folder structure or tell it exactly where on the physical device to go using a full path. But in this case, we're just going to save it to the folder we're in. And then you'll see there's a mode here, and it says open text mode. Initially, it's going to open in text mode R, which stands for just read. But there are a lot of different text modes. Text modes include R for the default read only, W, which opens a file for writing if the file doesn't exist, X, which creates a new file if the file doesn't exist, A, which is like an append mode, which is kind of like a write to mode. If it doesn't exist, it creates one. B, which is to open it in like the binary mode, and X plus sign, which will open a file for reading and writing, and it's good for updating. So we are actually going to combine two modes. We're going to do the W plus mode, and the W plus is going to open up our mode for reading, writing, and it'll create one if one doesn't exist, which is perfect for our purposes because as we begin right now, it does not exist. So that's what this is here. This is this mode. It needs to be in quotes like a string. And then we're going to go ahead and write to our file, which is just basically, this is a text file, so we're just going to pass it a string. And then we're going to close our file. You do want to close your file before you continue on with any work. I'm going to show you another method later that says that will open a file, allow you to do some work, and then automatically close it at the end in case you're going to forget. But this is just important to remember to close your file. Now let's look at how we would read from this text file. And we're going to do that by, again, declaring F and setting it to open the text file we just made. With a mode of R. R, remember, is the default mode, and it's read only. And it won't create a file if there's not one in there. So that's also important to note. And I'll show you later what happens when we try to open something that doesn't exist. We're essentially going to store in the variable data all of the information we're going to read out of our file, which at this point should just be this is a test, that string. And then we're going to, again, close our file. Excuse me. And then let's go ahead and print out the data in our file. So now let me show you the power of this. I'm going to, let me actually clear my screen here. I'm going to run our file access program that we've just written. I'm going to go ahead and make this a little bit bigger. Okay, great. Actually, we got an error right off the bat. So let's see what that says. F open, no such file or directory exists, text.txt. Okay. That's perfect. It shows us the problem right up front. So we made a file called test.txt, But when I was retyping this, I miswrote this as text.txt, and we got an error because the R mode does not create a file. It tries to open something, and because it wasn't there, it went ahead and ran an error. So we're going to fix that error, change that back to test, and run this again. And you'll see we have the data, this is a test. And we ran it again, we get this is a test. Every time it's opening this file, adding this data to it, and closing the file again. It's actually kind of remaking it every time, so it's not appending it to it. It's like clearing it and adding this data. Like, this is the file I want to write to that now. This is the file I want to write to that now, with no consideration for what was in that file beforehand. Now, if I comment out the part of our program where we make and write to the file, but I call this program again, it's still going to have this as a test, which is my point about data existing beyond the run of a script. And you'll notice down here, this file has been created. This is newly created since we ran our program. And inside it, it has our data. This is a test. So let me show you again. I'm going to go ahead and I'm going to delete this. Go ahead and move that to trash. I'm going to uncomment our creation of that file. And when I run this program, I want you to watch this list over here, and you'll actually see that file pop up. Ready? There it is. So it's creating it, it's adding that data, and then it's closing that file. And if we look in that file, we can see that data is there. And if we go back to our script, and we no longer, or we wanted to, if we wanted to edit this, notice that it's going to edit what's actually in that file, not add to it. This is a test 2. This is a test 2. This is a test is gone now. And that is saved. That is saved in our quote-unquote permanent storage, so that if we wanted to run this without actually making the file, you could make the file the first time you run a program, it stays there, and then every time you run that program, you'd have access to that information. .text files is not the only type of file we can use. Another common file, especially for information about a program, is what's called a CSV, for databases at least, which is a comma-separated file. It's like a text file, except different pieces of information are specifically delineated by commas. So you'd have a piece of information, a comma, another piece of information, a comma, so on and so forth. And that's a way of structuring data, almost like a spreadsheet where the commas indicate different cells and the actual rows of the paper indicate different rows. So you're kind of making, if you can imagine an Excel spreadsheet or a Google Sheets spreadsheet, you're making the same thing. You're just doing it all with text instead of with boxes. And the thing that delineates the boxes are the commas. Thus why it's called a comma separated file. And we're going to work with that a little bit soon.